Hello, Sonanta.
Hi, Miss.
So today we are going to study about exponential sequence. So exponential sequence is also called as geometry. So we have studied till now uh, arithmetic sequence and geometric sequence. So let us understand what is difference between an arithmetic sequence and geometric sequence. So you remember you have done linear sequence, quadratic sequence, cubic
Yeah,
sequence, right?
yes.
So all those belong to arithmetic
Arithmetic.
sequence. So when we have a arithmetic sequence, each term, the difference between each term, either we get it by adding or subtracting. So this is the main thing what you have to remember,
Okay.
right?
Yeah.
Okay. And then when we speak about exponential or geometric sequence, we get each term either by multiplying or by dividing.
Multiplication.
Generally, we can call it as multiplying only, and we refer this as ratio. And here in arithmetic sequence, how we get the next term, that is referred as difference. Hope you are aware about this.
Yes.
Yeah, so you must be remembering that when we speak about linear sequence, the difference is a. When we speak about quadratic sequence, the difference is 2a. And when we speak about a cubic sequence, the difference is referred by 6a. Am I right?
Yeah.
Okay. And when we speak about a geometric sequence, the we don't have a difference, rather we have a ratio that is referred by r. Is this clear to you?
Yeah.
So general rule for finding the geometric sequence is so it is ar to the power of n minus 1. Okay, where
Yes.
a is the first term of your sequence. Okay,
Yeah.
a is the first term of the
First,
sequence, and
R
r
is
is
the
the
ratio.
ratio between the terms. Am I clear?
Yeah.
Very good. Okay, let's see few examples. And how we find the ratio? We find the ratio by writing like this: second term upon first term. Okay.
Yeah.
Okay, you can also refer it as A2 upon A1. And okay, you can check for the whole sequence whether they are in geometric sequence or exponential sequence by putting third term upon second term, fourth term upon third term, like that, finding the ratio. Clear?
Yes.
Very good. Now let's see this example here. So this question is, identify which of the following are exponential sequences and which are not. Okay, let's go with this A, 2, 6, 18, 54. Let's write this. 2, 6, 18,
18, 30, 54.
54. Sorry, 54 it is. Okay, now let's find the ratio. First we have to identify whether they are in geometric sequence or not. So we have to find the ratio, and you know what is ratio? Ratio is
6
obtained by second term then
and
first
the
term.
first term.
Okay, so
6
this,
over 2,
yes,
3
that
is
is
equal to 3.
over
18
1.
over 6 is 3.
Yeah, we can, okay, we will just change it, 18 over 6.
Is
Okay,
3.
again 3, yes.
54 over 18 is also 3.
54 over 18 is also 3. Okay, it means the ratios are same between each term of this sequence, therefore it is a geometric sequence. Is this clear to you?
Yes, miss.
Okay, now what we will do, we will find the nth term. Okay, so our ratio is 3 is to 1, and now we have to find nth term. Okay, so what is the rule for nth term of a geometric sequence, you remember? Just now we did.
3.
The
Oh,
rule.
sorry. It's 5. 5
No,
minus 1. Because we have to find the 5, right?
No, that is another thing. AR to the power of n minus
N
1.
minus 1.
This is the,
Oh,
yeah,
formula. Okay, my bad.
yeah, this is the rule to find the geometric sequence.
Geometry.
Okay. Hmm. Now our sequence is, what is that? 2, 6, 18, and 54. 2, 6, 18, 54. Okay. So as I said, A is the first term. So A is 2. R, we have already done. R is 3. So let's input everything here in nth term rule. Nth term is equal to AR to the power of n minus 1, and A is 2, R is 3, n minus 1. That's it. This is your nth term. Is this clear to you?
Yes, miss.
Okay. Now here how many terms are given to us? One, 2, 3, 4 terms are given. Okay, suppose if I have to find the 10th term, got it?
Yeah.
Suppose if I have to find 10th term of this sequence, it's going to be very, very big. 10th term. Oh, let's change it. I cannot take that big number. 6th term. Okay, suppose I have to find 6th term of this sequence. So, see, 6th term and our nth term rule is 2 times
AI.
3. Huh. Following that, we are getting this. So, n. Here, n is 6, right?
Yeah.
So, what we will do, we will replace n by 6. So, 2 times 3 to the power of 6 minus 1, that
2
gives you 2
times
times 3 to
3
the
to the
power
power
5.
5.
Okay, so you will get here, 2 times 243, that is 2 3 is 6, 2 4 is 8, 2 2 is 4. Is this clear to you?
Yes, miss.
No doubt?
No.
Very good. So let's go for another one. This one is 25, 5, 1, and 1 over 5. So 25, 5, 1, and 1 over 5. Okay, first we have to check whether this is in geometric sequence or not. Okay, so we need to find the ratios. So it will be 5 over 25. Another ratio we will find 1 over 5. Another ratio we will find is 1 over 5 over 1. Okay, let's figure out this one. This is 1 over 5. This remains as it is because we cannot simplify it further, and this one becomes 1 over 5. So you can see here the ratios are same. Therefore, this sequence is in geometric sequence.
Geometrical sequence.
Got it? Yeah.
Yes.
Now, once we have figured it out that this is a geometric sequence, let's find out the nth term. Okay, so what will be the nth term? Nth term rule is
And
A.
AR and O
Hmm?
to the power n minus 1.
And R to the power of n minus
N
1.
minus 1.
Okay, so how do I find the nth term after this now? What will be A in this question?
It is gonna be 25.
Very good. R is?
1 over 5. That is 5. 1 over
Mm-hmm.
5. And
Okay.
n is
N
gonna
minus,
be.
no, no, n minus 1, that's it. This is our
Okay.
nth term rule.
Okay.
Right?
Okay.
Now, if I ask you to find the sixth term of this sequence. Okay, find the sixth term of the given sequence. So what we will do, we
So
have nth term.
25.
One second, beta. Nth
Okay.
term is equal to 25.
25 times
Huh.
1 over 5
Hmm.
to the power 6 minus 1.
Very good. Hmm.
That is 25 times 1 over 5 to the power 5.
Very good. Okay, so we will have 25 times 1 over 5 to the power of 5. So that will be, actually, that will be 25 times 25 into 5. So this gets cancelled. So you get 1 over 125. So this is our sixth term. Is this clear to you?
Yes, miss.
Any doubt?
No.
Very good. Let's try one more. 1, 4, 9, and 16. 1, 4, 9, and 16. Let's see whether this is in geometric sequence or not. 1, 4, 9, 16. Hmm? So we will find the ratio 4 over 1. Then another ratio is 9 over 4. Another ratio is 16 over 9. So here we get 4. Here it cannot be reduced further. So n over 4 remains same. Okay. And then 16 over 9 also remains same. So this is not in geometric sequence. Am I clear?
Yes.
Any doubt in this?
No, miss.
Okay, very good. Now let's pick one more question. Rest of these you can try by yourself.
Okay.
Okay. Now this question says that find the common ratio of the whatever is given in question one. So we have done this. Next two terms you can figure it out. Okay. Okay. And then formula for the nth term. Mm-hmm. Okay. So we didn't do how to find the next two terms. We will do that. I'll do that. Okay.
Mm.
So if we our question number 1, 2, 6, 18, and 54. Your nth term is, and this is 1, 2, 3, 4. This is the fourth term. Our nth term rule is here what we got 2 times 3 to the power of n minus 1. Okay. So find next two terms of 2, 3, sorry, it's not 3, 2, 6, 18, 54. Okay. So next two terms mean we have to find the fifth and sixth term, right?
Yeah.
And our nth term rule was nth term was 2 times 3 to the power of n minus 1. So we can figure it out. Fifth term will be 2 times 3 to the power of 5 minus 1. That will give you 2 times 3 to the power of 4. That is 2 times 81, and that is 168. I think so we have done it somewhere. And the sixth term we have calculated here already, right? As an
Yeah.
example. So this is clear to you hopefully. Okay.
Yes, miss.
And then we will do this here also. We have to find fifth and sixth term. So sixth term we have already done. Okay, so we need to only do fifth term. So when
Mm.
your geometric this sequence nth term rule is this thing, so we can find the fifth term now. So no, not like this. So I can say find fifth term here. So fifth term will be, since you have this rule, 25 times 1 over 5 to the power of n minus 1, and will be replaced by 5. So you will have 25 times 1 over 5 to the power of 5 minus 1, and hence you have 1 over 25 into 1 over 5 to the power of 4. 5 to the power of 4 will be 625, and then you see you get the answer as 1 over 25. Okay.
Yeah, miss.
So this you understood, I know. Let's try one full question here. So the question is the nth term of an exponential sequence is given by the formula Tn. So it is already given. Tn is equal to minus 6 times 2 to the power of n minus 1. You have to calculate T1, T2, T3. T1, T2, T3 means you have to find the first term, second term, and third term. So T1 will be minus 6 times 2 to the power of 1 minus 1, because n is 1. And you know that this will become 2 to the power of 0, which means 1, and hence you get the first term as minus 6. Is this clear to you? Is this clear?
Yeah, miss.
Then we have to find the second term. So it will be minus 6 times 2 to the power of 2 minus 1. So you
1.
get minus 6 times 2 to the power of 1 is 1, and hence
1.
you get minus 12.
Okay, got it.
Okay. Then T3 is also asked here. So you will write minus 6 times 2 to the power of 3 minus 1, that is 6 times 2 square, and that is 24. Got it? Is this clear?
Yes, miss.
So we did T1, T2, T3. Now the next question is, what is the value of n if Tn is equal to minus 768? So this question means that there is a term in your geometric sequence that is minus 768, right? Okay, find the value of n means you have to find at which position you can find this term. Understood? Okay, so we have to use the for this nth term rule. So nth term rule says minus 6 times 2 to the power of n minus 1. I have to figure it out what is n, and this is equal to minus 768. Until here it is clear to you. Any doubt?
No doubts, miss. It's clear.
Okay. Now, so we will do 2 to the power of n minus 1 equals minus 768, okay, over minus 6 you got. Then we cancel it, and 2 to the power of n minus 1 will give you 6 twos are 12, and 6 eights is 48. Until here it is clear?
Yeah, miss.
Clear. Okay.
Yeah.
Now we have to find the value of n. Okay. Now, so how do we solve this now? Exponents. You have to write 128 as a base with 2. Okay. So can you write 128 as base 2? Yes, we can. See, right? 1 2 3 4 5 6 7. Okay, so 2 to the power of n minus 1 is equal to 2 to the power of 7. Since the bases are same, so I can say n minus 1 is equal to 7, and n is equal to 7 plus 1, that is 8. So I can say that minus 768 is our eighth term. Is this clear?
Yes.
Right?
Hmm.
So the only thing is these are little bit lengthy, little bit tricky when it comes in exponential form here at the end. You need to practice many more questions.
Miss, can you
Okay?
like repeat the T8 one? I didn't get that properly.
Which one?
The T8B. 3B.
3b. This
Yes.
3b, that is minus 768. Right?
No, I
This one.
didn't I didn't like understand that properly. Can you like again?
Yeah, sure. So okay, I'll do here in the blank page. So you have to understand that our nth term rule here is Tn is equal to minus 6
Minus.
times 2 to the power of n minus 1. So Tn is equal to minus 6 times 2 to the power of n minus 1. Let me cross check. Minus 6 into 2 to the power of n minus 1. Okay, and our Tn is minus 768. Okay.
Yeah.
Now, see, beta, one thing you have to understand that this nth term, this nth term rule, what it suggests, it says that if I follow this rule, I will get whatever term I have at this position at n, and the value of n is 1 2 3 4 5 6, and it keeps on going, right?
Yes.
Now, here I have the value of Tn, and I have to figure it out what is n. For which place in the sequence I have this value minus 768. Okay,
Okay.
therefore, this nth term rule, this is the nth term rule, I can write it this way: minus 768 equals minus 6 times 2 to the power of n minus 1. Is this clear to you why I am writing
Yes.
this? Okay.
Mm.
Now to solve this, you bring that multiplier here and then you get it like this. Okay, and
Mm.
then divide 768 by 6, so you get 7171 16 7 sorry 6161 and 6 2s 14 and 6 8s 48. So you get this as 2 to the power of n minus 1. Now our next step is to figure it out what is the value of n. To
And
find this value of n, since here the base is 2, I should write 128 as base 2. Did you understand?
okay.
Okay, so this you have studied in index notation. So how? So we can do it like this. You can use your calculator as well here, but avoid using calculator wherever possible. Okay, so I'm
Okay.
doing it. See, 1, 2, 3, 4, 5, 6, 7. Okay, so I will write 2 to the power of n minus 1 equals 2 to the power of 7. Until here it is clear to you.
Two, two.
I made the bases same. Until here it is clear?
Oh, okay, miss. Two to the power. Miss,
Yeah.
wait, how? One, two, three, four, five, six. One, one, two, three, four, five, six.
7. 1, 2, 3.
Oh, the two. How many twos are there? You count that?
Yeah.
Okay, okay, miss. Okay, miss. Got it.
Okay. Yeah. So 2 to the power of 7 is 128. Because the bases are same, so we can equate this. N minus 1 equals 7 and hence n is equal to 8. It
Mm.
means that at 8th position in the given sequence, I will get this term minus 768. Is this clear
Okay.
now?
Got it, miss.
Okay then. Very good.